Welcome back to lecture 8. So in our last lecture, in lecture 7, we learned how about relations and functions, and we have seen the difference between a relation and function, and we learned when a relation becomes a function. Okay, when we what does it have to satisfy in order to be a function, and how do we check whether it's a function or not? For example, graphically, we have the vertical line test. And today we will see linear equations, what linear equations and in two variables are, and then linear functions. Basically, it's only the notation, otherwise they are more or less the same. So given A, B, C, we have, let's say, these real numbers. Since they are arbitrary, we use these letters. And we want A different to be from 0 and B different to be from 0. And then the linear equation in two variables, x and y, is given by this form. This is the general form, the standard form of a linear equation in the variables x and y. Okay, so the standard form of a linear equation is ax plus by equals to c. Well, there are different forms, of course, but this is what we call the standard form. We have the constant, c is a constant, so we have the constant on the right side, and we have coefficient of x, which is a, and coefficient of y, which is b. And for example, we can have, let's say, we can have 2x plus 3y equals to 4. Now, if we look at this one, this is exactly the same with this one, because a is 2, b is 3, and c is 4. So this equation is a linear equation, and it's written in a standard form. Or we can have, for example, let's say I can have 3x equals to y plus 4. Now, this is not in standard form. Now, how do we write this one in standard form? So in order to write this one in standard form, you have to make it look like this one, which means we have to bring the variables, all of them, to the right side, and the constant to the this to the left side, and the constant on the right side. So to do that, then I write this one 3x, and we bring this one to the left side, and it becomes negative y, and then I have 4 on the right side. So now we write the equation in standard form. And another thing is, okay, if we have an equation given in NO form, but for now let's consider it's in standard form. If we have, for example, to make it simple, I will just write x equals to y. I'll write it in standard form. X plus y equals to 1, just to make it simple. So suppose we have an equation, a linear equation in the variables x and y, and we want to plot the graph of this function, this equation. So what we could do is, what we can do with this one is, let me put this one first. Okay. Then we create a table for y and x. Then pick arbitrary values for x. Let's say -1, 0, and 1. Okay, these three numbers, I will pick this arbitrary values for x. Now, for each value of x that we choose, we solve for y. So if we substitute -1 in here, we get -1 plus y equals to 1. Then subtract, add 1 on both sides, we get y equals to 2. So this is 2. We substitute 0 in place of x, we get y equals to 1. We substitute 1 in place of x, then we get 0. Now, you plot these paired values on this Cartesian plane. Okay, so let's find this point. -1, x is -1. So x negative means it's on the left side. -1 is here. And y is +2. We go up. It's right here. And then the second pair, or the second point, 0, 1. X is 0. X0 means it's at the origin. Well, not the point, but x is here. X equals 0 means here. And then y equals to 1 is here. So the intersection is right here, not this one. And then the third one is 1, 0. 1, 0 is x is 1, so it's right here. And y is 0 means the x-axis. Therefore, the point is here. Now, if we connect these points, we get something like this. Okay, so this is the graph of x plus y equals to 1. So for now, this is how we can graph, or how we can plot graph of a function, an equation for now. Okay, and later on we will see another way of plotting a graph, plotting the graph of a function or an equation in 2 variables. Another important thing that we need to know is the slope of a line. So slope means the steepness of the line, how steep it is. For example, you can have a line like this, horizontal. We can have like this one. We can have like this. And maybe we can have down like this one. It goes downward. And maybe like this one, or vertical. Okay. So how do we tell the steepness of these different lines? And to answer that question, we need to find the slope of the line. So what is slope, or how do we find slope? So suppose we have a line that passes through the point x1, y1, 2 points. This is point 1. So we use x1, y1. And point 2, we use the coordinates x2, y2. Now, m is the slope of the line. So the slope is change in y over change in x. And sometimes, or in some books, you may find this one, rise over run. Okay, so if we have this line, the slope is when I go, for example, to the right, specific or some distance horizontal, then what is the vertical? Okay, so this is, for example, the change. Run is here, and rise is this one. Okay, therefore, change in y means delta y, change in x is delta x, and delta y means the difference between these 2 y values. Okay, y2 minus y1. And delta x is the difference between these 2 x values, x2 minus x1. Okay, so here we have to be careful. For example, if I give you 2 points, 2, 1 and 3, let's say -1. Now, which one is point 1 and which one is point 2? Should I subtract, for example, this is -1 minus 1 over 3 minus 2, or which way? Well, the answer to this is it doesn't matter. You can take this one as point 1 and this point 2, or this point 1, this point 2. But one thing that you have to be careful in this is when you subtract y2 minus y1, for example, if you start with this one, if you do -1 minus this is y1 minus 1. If you do this one, you have to follow the same with x as well. You start with this one and you subtract that one from this first number. Okay. Again, if you start with this y, if you do 1 minus then this y, which is -1, then you have to do again, you start with this one and subtract this. Okay. And do not do, you have to be careful of not doing this. For example, if you start with this, for example, -1 minus 1, subtract this from this one, and then the other way around. For the y, you start with this. For the x, you start with this one. This is wrong. Those two are correct, okay? But this is wrong. This is not right. So that's the only thing that I want you to be careful of. All right. And here we say x2 minus x1 should not be equals to 0. We want it to be different from 0. And why is that? Because if this is 0, then it becomes undefined. And that's why we always put a restriction. Now let's work on these examples. Suppose we have a line that passes through these 2 points. These are the 2 points, okay? And we are asked to find the slope. So what is slope? Well, this is delta y over delta x. And this basically means y2 minus y1 over x2 minus x1. Okay. And now what is y2? Well, I will start with this one. I will take this one as y2. So 3 over 10 minus y1 is 2 over 5. And then x2 is 4. y2, x1 is -3. Now we simplify this and we get 3 minus 4 over 10 over 7. This is -1 over 10. -1 over 10. You have to remember this one, how to perform this. So you take the reciprocal of this one and multiply it by this. So this becomes 1 over 7. And this becomes -1 over 70. Okay. So as you can see, the slope is a small number. 1 divided by 70 is a small number, and it's negative. So the negative means it's going downwards. Okay, it is going downward. And the size, this magnitude, 1 over 70 means the steepness. So it's not that steep because it's very small. So maybe it's like this, something like this. But you can try and plot the graph. How about if we have this graph? If I give you a graph, and if I ask you to plot to find the slope, well, how do we find the slope? What you could do is just pick 2 points, because here this is we have the grid, so you can easily find the point. So for example, this is 3,2. So just pick 2 points. One is, for example, this, and another is I can pick this one. These 2 points, they lie on the line. So I can find the slope. M equals to, this is 3,2. This is 3,0. So y2 is 2 and y1 is 0, and x2 is 3, x1 is 3. What do we get? 2 over 0. And what is this number? This is undefined. Okay. And now we have a slope which is undefined. And what does that mean? Well, as you can see, the vertical line, this is a vertical line. And we have a slope which is undefined. And now we can conclude that the slope of a vertical line, any vertical line, not only this one, but any vertical line, has a slope undefined, which is undefined, okay? Which means it doesn't have a slope. Well, I cannot say it doesn't have slope, but the slope is undefined. That's the best way to express it, okay? So whenever you have a vertical line, and if you're asked to find the slope, you don't need to calculate it. Just that's undefined. Or if, for example, if I give you 2 points, and if you're asked to calculate the slope, and if you get undefined, then you know that line which passes through those 2 points is a vertical line. And another case is if you have a horizontal line, then let's see, suppose this is 0, 2, and I will take this one as 3, 2. Now the slope for this one is 2 minus 2 y2 minus y1 over x2 is 3 minus 0 is 0 over 3. And what is this? This is 0. Now again, if you have a horizontal line, then the slope is always 0. Okay, for any horizontal line which is horizontal straight, then the slope is 0. Okay, so these are 2 special lines with known slope. Okay, one is undefined. Undefined is a vertical line. When the slope is undefined, it's a vertical line. And when the slope is 0, it's a horizontal line parallel to x-axis. Okay, and this is parallel to the y-axis. All right. Now, how can we find the slope? Well, this is another way. Earlier we've seen the standard form of writing an equation in 2 variables, and another way of writing such an equation is using the slope-intercept form. And this form is, suppose we have m, which is the slope, and we have the y-intercept, which is given always as 0, b, because the x value is always 0. When it's y-intercept, this is always 0. But the y value is, it could be 0, it could be different from 0, okay? So we write it as 0, b. b is some value, which is, this is what we have. So the slope-intercept form of the equation is given as y equals to mx plus b. Now here, if you notice, this is the slope of the line, this is the intercept of the line, okay? And here in the equation, we just use the slope as a coefficient of x and the intercept as a constant plus b. b is a constant here, okay? So this is very, very informative and very helpful when plotting or dealing or finding slopes and intercepts, okay? Now, for example, if we consider this equation, the first thing that we need to do is, well, we're asked to find to graph the equation and using the slope and intercept and y-intercept. Okay, so first let's write this one as in the form of in slope-intercept form. To do so, we isolate this y on the left side. So we write, this becomes, let me use this color, 0.04 y equals to 0. Now this becomes negative because I'm moving this one to the right, 0.3x plus 0.12. Okay, and now we divide all by 0.04, 0.04. So we have y equals to negative 0.3, 0.04, x plus 0.12 over 0.04. Okay. Now, if we simplify this, because as you can see, we have decimals here, so it's always a good idea to get rid of these decimals. Even you can do that one at this step. You can multiply all of them by 100, both sides, okay? That's probably the best way, actually, multiply all of them at this step. but still we can do it here, and I'm gonna multiply them by 100 for the denominator and numerator. Okay, so here we have, I will multiply this by 100 over 100. I'm not changing anything. And then we have 0.12, 0.04. And again, I will multiply this by, since it's 100 over 100, it's still 1. So when you multiply a number by 1, it doesn't change anything. So we are not changing the equation. Okay, so here, what do we get? Negative 3 over 4. When you multiply this one, you get 3. And here we get 12 over 4. And 12 over 4 is 3. So I will just write 3 here. Okay. So here we have the slope-intercept form. This is the slope-intercept form of the equation. Now the next is, what is the slope of this line? So from here, m is just this number, including the sign in front of it. So this is negative 3 over 4. And y-intercept is, now here we have 3, right? And this is b. And the y-intercept, we say, we write it as 0, comma b, right? But b here is 3. Therefore, this is the y-intercept. We write it 0, 3, not just 3. Now the next question is, how do we graph? How do we graph this equation? First, let me put this Cartesian. Okay, and here we have all right. So now first let's spot the y-intercept. 0, 3 means 0 is here, so 3 is here. So the point is right here. That means the point, the line crosses the y-axis at this point, or it intersects the y-axis at this point. Okay, and then we use this slope to plot the graph. Okay, so here we have m equals negative 3 over 4. And what do we know? M is, from the definition, rise over run. Rise over run. So I will use this idea. Here, the rise is negative 3, and the run is positive 4. Okay, so let's follow this now. Rise means vertical, either upwards or downwards. Let's say now I will start from here. I will say this is one starting point. So we start from here, and let's follow. Let's go downward, because here this have a negative sign. So I will go down 3 points. So here we have 1, 1, 2, and 3. So we stop here. Okay, and then run is 4, which means 4 points to the right. And this is 3 downward. Okay, so we came 3 downward, and now we go 4 to the right. So 1, 2, 3, 4. It is 4, and we are right here. Okay, therefore this is another point that the line touches. Okay, so if we connect this, we have the line which looks like this, and the line of the equation of this is y equals to -3 over 4x plus 3. Okay, so this this line is the line of this equation. So this is how we can use the slope-intercept form to graph or to plot the graph of an equation. Okay, you can use the definition run over rise. So you identify your the run and the rise, both of them, and then it doesn't matter. You can even start with the run, and then you can follow the rise. Okay, but either way, you follow like one of them. If it is going downward, you come downward, and then right or left, and then the end point. Once you follow both of them, and the last point that you arrive, that is the point where the second line or the point the equation crosses, or the graph of the equation crosses. All right. Now we've seen this as an equation, and we learned functions in our last lecture. So here we can just use the function notation instead of equation, and we replace the y by f of x. Okay, that's the only difference now here, because the slope-intercept form of y is mx plus b. Now I replace this one by f of x equals to mx plus b. So this becomes a linear equation. That's what we have here, linear function, sorry. So this is a linear function, okay? And then if you have f of x equals to b, this is called a constant function. The graph of this line, this function, is always horizontal. Okay, the graph of this function is always horizontal because there is no slope. The slope is 0. As you can see, it doesn't have m, right? There is no m here. So since the slope is 0, the graph is horizontal. So for any constant function, the graph is always horizontal. It only depends on b. Where does it touch the y-axis? Is it at 3, at 4, at 100? That's the only difference. Otherwise, it will be horizontal. So here we have a point. Well, this is not y-intercept. This is just a point. So it passes through this point, and the slope is given by this one. Okay. Now, how do we find this? Well, we know using the y-intercept form, we have y equals to mx plus b, right? This is any point. It's not the y-intercept. And here we have m equals to, we know the slope, so it's -5 x plus b. Now we're trying to find what b is. So I will use this point and solve for b. So use this for x, substitute this one here and this one here, and then we get -8 equals to -5 times 2 plus b, and we have -8 equals to -10 plus b, and add 10 on both sides. Here we get 2, and here we get b. Therefore, b is 2. Okay, so the question is to write the equation using a function notation, right? Now the slope is given, it's -5, and I found b. We calculated b, right? We solved for b. Therefore, equation is given by y equals to mx plus b. So if I follow this, y equals to -5x plus b is +2. But the question says we want this to be in a function notation. So instead of y, here I will use f of x equals -5x plus 2. Therefore, this becomes equation of the line which passes through this point and has a slope equals to -5. Okay, so given any point, given any point and a slope, we can find the equation. Again, another way is, or not another way, but another possibility is given 2 points. If I give you, for example, 2 points, x1, y1, and x2, y2, if we know the line passes through these points, okay, then without any further information or other information, we can find the equation of this line. Just if we have 2 points, if we know 2 points that the line passes through, then we can find the equation. Another is we need this information. We need 1 point and a slope. In this case, we don't need the slope. We don't need this one. Okay, we don't need. So this is how we can find equation of a function. And this is how we write. And as you can see, this is a linear function. Okay, so to sum up today, to summarize, we learned the linear function in a constant. We have seen different forms of an equation in 2 variables, the standard form and the y-intercept form. And we have seen how to find the slope and the intercept. And then now we know how to write or how to find equation of the function with a given point and a slope. Okay, so that's it for today, and see you in the next lecture.